Yikes. Hey everybody, it's Mr. C, and welcome back to another day of learning right here online. Very excited to have all of you back, and we're going to get started here in just a moment. I've got my hair dryer and a ping pong ball. We'll talk about that in just a moment. What I want to do really quick is I want to make sure everything's working. Looks like it is. Here we go. Let's make sure we are live. And I can see it. We are live. So excited to be back. And if you don't know who I am, my name is Mr. C. I'm actually an educator of 18 years. I used to be a 5th grade science teacher. And now I travel all around the country in different places doing live shows. But because we can't do live shows right now, we're bringing some of the fun to you at home. And if you joined in yesterday, you know we were talking about air. We talked about air is made up of matter. We know that air can be powerful and creates pressure. But today what we're going to do, as promised, I brought a vacuum pump and a vacuum bell jar with me today. And this is going to be a lot of fun because we're going to try putting different things into this to see what happens. Now you're wondering, what is a vacuum pump and what is a bell jar? So inside of this container, it's a little wet still because I had cleaned it off really well for you guys. Inside of this we have air, right? We can't see it, it's transparent, but it's filled with air. In this room, in your room at home, it's full of air. And what we're going to do is this vacuum pump, just like the vacuum at your house that sucks dirt and grime up out of the carpet, this vacuum pump pulls air out of containers. And what we have is this container. When I put this onto this plate, this is a vacuum plate, and what I have are a couple of valves here. So the air is going to get pulled from this out here, and I have this turned off so air can't get sucked back in. And I'm going to turn it on here in just a second so that we can see what or if anything actually happens. So today's presentation obviously is going to be a little bit noisy because when I turn this on, it's going to be like wah, 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 wah. So be prepared. So if you need to turn down your volume at times, just hit that mute button and come back live, or it's actually not as bad. It sounds like this. Oh, I should plug it in. This is what happens when you do live shows from your house and you can't find the extra surge protector. All right, here we go.
It's just like speakers and Beakers.
Yeah, it's like a real show where we make mistakes. There it is. So it's not too bad. It's a little hum. So what we're going to do is turn that on, and then I'll show you. We're going to pump out some air. And so, like, we've done that, and now what we'll do is I'll just lift it back up so you guys can... What? The vacuum plate got sucked. Oh my gosh, the vacuum plate got sucked to it. All right, hold on. I'm going to open this back up. Did you hear that? That is air. And my question is, was the air rushing into the bell jar, or was it rushing out of the bell jar? But anyway, let's open it back up. And now I can open it back up. I can lift it up. So I'm going to do that one more time. So think about what's happening. This bell jar has air inside of it. We can't see it. It has air. When I turn this on, oh, it looked like it made a little cloud. Did you see that? It like, all right, so we're going to take the air out. So we've removed some of the air, not all of it. It's a partial vacuum. And we've taken some of the air out. And now, just like yesterday, if you remember, we were able to hold the water upside down in the cup. The air down here is able to keep and hold this up because there's less pressure inside of the cup. We've removed that air. So I know you guys want to get down to business. And we did some hunting yesterday in our house. We had recommendations for ping pong balls. So we've got some hair-raising science, Mr. C ping pong balls. I have got a balloon that I already partially inflated, so we have a little bit of air inside of this. It's a happy balloon, so see what happens there. We were looking for rubber ducks, and you can see we have some rubber ducks, but they're not really sealed off. But I found our little princesses, which are like rubber ducks. So we'll put a princess inside of our bell jar. All right?
Bell.
Is it Belle? That was by accident. We put Belle. We're gonna put Belle inside the bell jar. Beauty and the Beast. All right, so we've got her. We've got this. So we'll put those in. I also brought some shaving cream. We're gonna do this one last because if it makes a mess, kind of like I did yesterday, we're going to come back to it. And a whole bunch of things. So instead of me talking about everything we have, let's go ahead and get started. Let's start with something that we all are familiar with, a balloon. All right, I'm gonna put this in here. Now, I'm gonna put this little bitty plastic piece in here as well. And you might be thinking, why am I doing that? That's because if this balloon gets stuck on this hole, the air can't escape and we won't be able to do the experiment properly. So what we're gonna try is to put this on here to block that, and I have a little hole in it so that if it gets stuck to it, it can still have air sneak in underneath it. So we're gonna give this a whirl. Let's move this so everybody can see. So air is inside of this balloon. Let's see what happens. All right, here we go. Make sure we're nice and sealed. Oh yeah, look at that. Look how happy that balloon is inside of the vacuum pump. Keep going, you can do it, you can do it. Why is it not going any further? I think we have a leak. I think I can hear some air escaping. Someone tighten this up. Oh, it's because, yeah. Make sure that's nice and tight. We're gonna try that again. I thought I could hear some air. Either, ooh, it's warm. It's warm. Did you see that balloon expand? The air molecules inside of this balloon can't escape the balloon. But as the air in here gets pulled out, there's more space for the air molecules here to spread out. Gases want to spread out. They want to fill the container that they're in. All right, we're going to try this one more time. Put that there so we can, oh, let's see if we can see the face. Here we go. Oh, I bet it's going to knock over the plastic. Don't do it, don't do it, don't knock it over. And when I let the air back in, the air rushes in and it causes it to bounce all around. I've got a prediction. I don't know if it's going to do anything, but maybe this balloon is too small. Maybe we need a few more air molecules. Another. Excuse me. Put a few more balloons in here, and then we're going to move to something else. All right, here we go. So it's a little bit bigger of a balloon. Make sure we got everything hooked up. Here we go. That is awesome. Yeah, I can hear a little bit of air escaping. So eventually the balloon is going to deflate because the air is coming back in and it's putting pressure back on the balloon. But if we let it go really quickly, oh, this one didn't flip around as much. All right, so balloons, oh, it's so warm. It's because those air molecules are excited. They're moving around. They're bouncing around. There you go. All right. Belle, let's give it a try.
They'll let us know what they want next.
Yeah, if you're watching and you want to interact, let us know what you might be interested in seeing in here. We can put Mrs. C to work and have her find something, or we can holler for my daughter to find something. We can give it a whirl. All right, here we go. Close this off. I don't think anything is happening based on what I can see. Let's make sure it's working. Okay, so we know that the air is being pulled out because the plate is getting sucked and stuck to this. That was cool. But Belle is safe. Belle is safe. And I think what's going on, I don't know if you can see it there. There's a little hole. So the air that's inside of this molded plastic is actually just coming out of it, and it's not causing the air inside to expand. So Bella's safe for the day. I'm going to put you back with all of your other princesses. You are safe. All right, here we go. Let's try two things at once. We've got a ping pong ball, and then we have this. It's like a, what are those things called? At the, like...
Oh, like a ball pit.
Like a ball pit. So this is like a ball pit ball and a ping pong ball. So this is harder plastic, and this is softer plastic. But they're both sealed. And I've never tried either of these inside of...
Put some more ping pong balls.
More ping pong balls? All right. Here we go. Seal it up. In 3, 2, 1. You see it? It went like, what? All right, so we've got that. I'm gonna let the air back in. Every time. It's like a lottery machine. All right, here we go. So it went back to its shape. I could see it get distorted from my angle. It distorted it a little bit, so it spread out, but it didn't pop it.
Our video is interrupted, it says.
Uh-oh.
And it might not be interrupted up. I don't know where we are on the thing. Now it's back.
All right, we're back. It said our video was interrupted, so if you missed that, I apologize. But what we're gonna do...
Our friends asked if we have slime.
Oh, you know what? We don't have slime today. That's the one thing I couldn't find my baking soda. So I'm sorry I didn't make the slime. I was trying to make slime yesterday. I couldn't find the baking soda. I had my contact solution and glue, but I couldn't find baking soda. You know what we're going to do? We're going to try to look for it in the garage where I keep some of my stuff, and then we're going to try to make it. And we'll make a little video and then post it after this. Sorry about that. All right. I brought along... I have some marshmallows also. They're kind of stale. So marshmallows, if you don't know this, they are filled with thousands of tiny, teeny little pockets of air. So I want you to imagine that a marshmallow is like this balloon, but there are thousands of them squished into this little space. And what we're going to do is we're going to stack up a whole bunch. I wish I had those like jumbo ones that they sell like for campfires, but I couldn't get any of those, obviously. And what I have instead are stale marshmallows that are kind of sad. But we'll see what they do. We'll make a little tower of power. Oh, that's some sugary goodness. I can smell it. All right, here we go. Turn this on. Oh my gosh, look at him go, look at him go, look at him go. Wait a minute. They're shriveling back up. Let the air back in. They're like little raisins, look at this. I know, I've done this before, but every time, they're like so dense. They're still smell the same, but I'm not going to eat them because I've had all sorts of weird stuff on the vacuum plate. But they are so weird. They're like little raisins. I'm not kidding you. They're so weird. So it went from this, it expanded, and did you notice that the expansion then stopped? It stopped getting bigger, and it just started to collapse on itself. That's because all of those little pockets of air inside of there started to pop. They expanded so much that the air released, and then they went and got just smaller. They started to shrink. All right, we're going to do that one more time, because I want you to watch to see how those... I'm going to stack them. Man, I wish we had the big ones. I should have those jumbo.
When you take that plastic thing out, can you...
Oh, I could take the plastic thing out, couldn't I?
Yeah.
It shouldn't get stuck on that.
You can make a taller tower than that.
All right, this is the engineering design challenge for the day. Can Mr. C make a taller tower?
2 on the bottom.
But hold on, I gotta get more marshmallows. It's worth it. It is worth it. All right. All right, let's just fill this up.
Put them all in.
Should I put them all in? Yeah? Just like that? All right.
Oh, they escaped.
Here we go. All right, close this up, seal it. In 3, 2, 1. Oh, touch the top. Is it gonna make it? Is it gonna make it? Ah, no!
So close.
All those little things, all the little air pockets are popping. And then I'm just gonna turn it off. Oh. Look, they're all so sad. All right. That is super cool. That was awesome. Now I got marshmallow. I'll clean that later. All right. So, I wanted to try something. I haven't always been successful with this, but I thought it was about time that we gave it a whirl again, right? So I have a little stopwatch, like a little cooking timer that we use in the kitchen. I'm going to set it to 20 seconds. I'm going to set it to 25 seconds. Actually, I'm going to let it go for 25 seconds. And I want you to hear that it makes a sound. All right, so we're going to first test to make sure that it's actually working. And while we're waiting for that,
I don't know if we can see the time.
oh, you see the time? Should be going off any second now.
5. Oh, 3, 2.
All right, so we can hear, right? It's making sound. Stop. I'm going to start it again. And this time we are going to see what happens if we can remove as much air from around the stopwatch. So you heard that sound, right? We know that sound travels through different things. It can travel through wood, it can travel through metal, but we know it mostly because it travels through air. So when I'm talking and you're at a show with me, a live show, my voice travels and makes vibrations, and the sound wave travels all the way to you, and you can hear it in your eardrums. Your eardrum vibrates, sends a signal to your brain. So what we're going to do is I'm going to start this 25 seconds, and then we're going to let it go for 25 seconds. I should have hung it so I can see the time next time. Ah!
It's getting noise.
Huh?
It's getting noise.
Yeah. All right, it's going off. I'm going to be really quiet here at the house. Can you hear it? I can't hear it either. Let's see if it's going off. That is awesome. So when we remove the air from the vacuum pump, the sound can't travel through the pump. And you're probably thinking, yeah, but maybe it was already working before. Like, we couldn't hear it before. So I set a 5-second timer. Can you guys hear it? It's going off. So I wanted to show you that when it's going off in the vacuum bell jar, with air inside, we can hear it because the air is vibrating, and then it's vibrating the glass. And actually, because that is touching the plate, it's vibrating through the plate, and we hear that sound coming through. Oh, that's really cool. When we do some sound experiments, we'll have a lot of fun with that as well. All right, so that was our clock. What else do we have here? You guys are like my science peeps at home. So I was digging through my equipment and I found some additional Peeps. And these are actually still, they're not stale yet. They expire May 2020. So I'm really excited that I found these.
When are they from?
When are they from?
Yeah, when did you buy those?
Oh, I bought these. I bought these last year, I think around Easter time, about the same time. So I've had them for a year. Oh, they're stale.
So should we make a prediction?
They're stale. Hey guys, I'm a little peep, and I don't want to go inside the bell jar, but I'll do it for my peeps out there on Facebook and on the interweb. All right, so make a prediction. These are essentially marshmallows coated in extra sugar. So we're going to put a couple into this. All right, here we go. We'll do 3. We'll do 3. Huh? They're backwards. What?
I think that's the front. I don't know.
I think they have eyes. I think that's the front. Wouldn't that be the front?
But isn't that their beak?
I don't know.
It's the peep debate.
It's...
They're going to have to help us decide
What?
which is the front.
What side is the front of the peep? Is it this way or this way? This way or this way? Honestly, I don't pay attention to what side is the front because I just eat them. All right, here we go. I'm getting sugar and everything. That was a sound. All right, here we go. In 3, 2, 1. Oh, that's cool. That's cool. And they're expanding, 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 and eventually... Oh, they're holding their size better than the marshmallows. But there they go. Those pockets of air just busted. If I let it go... Oh, they look like sandals. Look. Oh my gosh. That's such a sad little peep. Alright, we're not going to eat them, but they're really cool. Don't worry. Don't worry. We will eat these because I'm not going to waste them. No, we shouldn't eat them. It says they're still good. They're a little stale, but we'll figure it out. We'll figure it out. I'll set those over here. Mrs. C says don't eat them. We'll put the stuff we're not going to eat on this side. You guys know what I'm doing. All right, let's wipe this off so we get a good seal. All right. I've got a Ziploc bag. That's a double zip, and this is a single zip. What we're going to try is I'm going to try to put this in there. Inside of this bag, the question is this came right out of our Ziploc bag box, and I thought, is it vacuum sealed? Like, is there any air inside of this? Or... you know, what's going to happen? I really don't know. So we're going to put this in here. All right, we've got to make sure that it doesn't... Ah! Ah! Got it. I trapped you, plastic bag. You have no chance. Belle survived. You'll be okay. All right, here we go. So if there's air inside of that bag, in theory, it should do something, right? So you're making that prediction. You're thinking about what's going on right here. And we're going to try this. Wah, wah, wah. It didn't do anything. All right, hold on. I got an idea. We're going to just open this. Put a little air in it. I'm going to close it now. All right, can you see? We've got some air in there. Now let's give it a whirl. Ah!
Then littler bags.
Huh?
Should have got the smaller bags.
All right, here we go. Here we go. Bless you. Gesundheit.
Hey, bless you.
You know what I wanted to ask? Not ask, but what I wanted to share? I looked this up. Just a little fun fact. This was created and invented and developed in 1650 by Otto von Guericke. Yeah, I think I didn't look, but based on the name, I think he might be German. Otto von Guericke. Pretty cool, right? All right, let's turn this on. And let's see what happens. All right. It's gonna keep expanding. Is it gonna pop? Is it gonna pop? That's pretty impressive. That's a Glad bag. Boom.
All right, now we have a mission.
All right, what's the mission?
Get it to pop.
Can we get it to pop? I wonder if we put more air in it initially, it'll pop. All right, so let's take a little bit and add a little more air. All right. There's probably an easier way to do that. All right, I'm having a lot of fun hanging out with you guys today. I hope that you're enjoying it as well. We're gonna put this in here, close it. All right, here we go. So we've added more air molecules in there, which hopefully will expand farther and pop. And I wonder if we would hear the sound based on the timer. All right, here we go. Oh, look, it got stuck. It got stuck. Hold on. It got stuck on the hole.
Did it pop it?
No, it didn't. It didn't tear a hole in it. It just sealed it. Okay. So we're gonna put that back in there now. I don't know why I'm having so much trouble with. There we go. All right. Oh, okay. I think we're gonna put some water. I want to try water. I want to try water too. All right, here we go. It made me jump. Go, 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 go. Oh, let's get it huge. It's getting huge. Oh my gosh, that looks so cool. I want it to pop. All right, here we go. All right, so that seal is tough. All right. What do we want to do? Oh, I've got this. This is the water bottle I used yesterday during the experiment. I'm going to push all the air out. I'm going to try to get as much air out of it as I can. I'm going to close it up again. I don't know if this is going to be a strong enough seal because it keeps like twisting on itself, but we're going to give it a whirl. So it doesn't look like it. It looks like it's completely empty, but what's inside? Teeny tiny bit of air. All right, here we go. We've got 2 more things after this, then we're going to call it a morning. All right, here we go. Here we go. Yeah, I don't think it's a good seal. And we know the air is coming out because every time it's shooting everything up, but the lid on that is just not a good seal. So that's something we might have to try again. All right, we need a little bit of water. We'll do a little bit more. It's one of my favorite reasons of doing science right here at my house is that
the moms are reassured that you make sure the bags are durable.
the bags are durable.
Ooh, someone said popcorn.
Boom! Great value. It is a good value to be able to do that with it. All right. So here I've got water. Oh, is that too big? Is that cup too big? No. All right, so I've got water in this cup, and I wonder what's going to happen to this water. I want to be careful with this also, because I obviously don't want to spill water in here. You know, Mr. C would never spill anything like I did yesterday. All right, here we go. So we're going to close the valve. We're going to pull out the air. And I want you to pay attention to the water. Can you see it, Heather? Is it a good shot on camera?
Yeah, I think so.
All right. Actually, I'm going to move it. I'm just going to move it to the front. I want them to be able to see if the water does anything. All right, here we go. Give it a second, give it a second, give it a second. I can see bubbles. And when water starts to bubble, we typically call that boiling, right? It's what we see on the stove when the water gets really hot. And some of you might be thinking, what's going on? Oh, come on, go, go, go. My machine is smoking. It's working hard. I don't think I have a good enough seal. Oh, I'm gonna open this up this way first. All right, did you see the bubbles? So the bubbles, the water actually, it's gonna sound weird, but the water was actually beginning to boil. And you're thinking, how is it boiling? Because it usually boils at 212 degrees Fahrenheit. Well, when we remove the atmospheric pressure that's around the water molecules can break apart more easily. So that's why when you're at higher altitudes, water boils at a lower temperature, because there's less air molecules that the water has to fight against to break apart to actually boil. All right, we're going to do one last thing.
Actually, can we add one more?
Sure. What do we got? Did someone say something?
Yeah, they suggested popcorn, and we have popcorn.
Popcorn? Like popped popcorn?
I'm guessing popped, but that would just be kernel corn if it's not popped.
All right, I got another cup here. Oh,
That's the cup.
we don't have any kernels, do we? Wouldn't it be cool if we could actually make like popcorn pop? Like air pop? All right, so we've got some skinny pop popcorn. It's the bottom of the barrel, isn't it?
It's not too bad on this thing.
All right, we'll leave it like that. So we've got some popcorn. Great request. All right, here we go. Ooh. I've got an idea. I think something's going to happen, but I'm not going to say it. I want you to make a prediction about what might happen here with our popcorn. All right, we're going to turn it on.
Oh, they should use a shallow dish.
Use a shallow dish? Do we have a shallow dish?
Maybe a plate?
I got an idea. I got an idea. What if we make a shallow dish? Oh my gosh, we are making a mess. All right. If I see popcorn getting sucked up in here, I'll turn it off. Ooh, I think we'll be okay. All right, here we go. It's like the bottom crumbs of our popcorn, so someone's been eating it. Turn that on. I don't see it doing anything. But I have a hunch that when we open up this valve, it's going to do something. All right, here we go. Watch it. That was cool. All right, we've got one more thing.
Somebody said that use a shallow dish of water and watch it freeze. Would it freeze with a shallow dish? I have to repeat what I said.
Say it again.
You might have to repeat what
All right, so we had a request that said use a shallow dish of water and see if it'll freeze. All right. So we're going to reuse our popcorn dish. All right, let's get some water. Hey, over in the office, can you grab the tape that's on my desk? Because I want to cover up these holes right here. We'll have to clean that later. All right. So I've got a shallow dish of water. We're going to try the water again, see what it does. And I just want to take a small piece of tape and cover up these holes so that water doesn't get... They're electrical plugs, so you can put stuff in there and experiment other ways. All right, here we go. Move the popcorn a little bit. Oh, I've got a bar of soap too. We had that request. Here we go. So it's forming little bubbles like it did earlier. but I don't think my vacuum pump is strong enough to pull out the air, or I don't have as good of a seal as I could possibly have. So I think that is part of the problem that I'm experiencing today. My only concern, I just don't want it to flop around the water. That is an awesome rush of air. But here, I'll show you the little bubbles. So we tested it though, right? It's hard to tell what the temperature is because I didn't pay attention. I could next time. I don't know if you guys can see the little bubbles still in there. There were no bubbles at the beginning, but then we have all these little bubbles form. All right, we've got Dove soap. Oh, what was that bar? What's the bar of soap that has like all the air inside of it? Do you remember? It's the bar. There's a bar of soap that floats. Is it Ivory? Yeah, so Ivory soap floats, and it's because it has a lot of pockets of air. I don't think we have any good Ivory.
Somebody else said fruit.
Fruit?
Oh, yeah.
Do we even have any fruit? I think we maybe ate all our fruit.
We need a micron gauge on it.
Yeah, I need some more science tools. And the person who just said I need a micron gauge, I like what you're thinking. So I need to talk to the missus and get some more stuff ordered. Yes, for sure. We need to get other cool stuff going on here. All right, here we go. Here's our soap. I don't think it's doing anything. My machine's smoking, the oil's burning off. All right, here we go. Nope. Wah, wah, wah. And our last one for the day. And then we're going to say goodbye. While I'm getting this set up and figured out, I'm going to dump this out. Yesterday we posted our song, Mr. C's hand washing song, Scrub a Dub. I'm going to encourage all of you to take the challenge. Take a video of yourself scrubbing your hands for at least 20 seconds washing. Post a video, hashtag Scrub a Dub Challenge. Let's join in together, have some fun, getting our hands washed, using preventative maintenance to prevent germs and those types of things. I'm going to put it right there. This is our last experiment. I have a hunch we could be making a mess. And if we do, it has been fantastic. All right, here we go. We'll get it set up. Can everybody see it? Here we go in 3, 2, 1. All right, I've got to watch this. I can't let it go into my vacuum. And touchdown. And we're going to open it up. That is a thing of beauty, and it smells very, very delightful. You guys have been fantastic. Tune in tomorrow at 9 o'clock. We are going to convert this hair dryer into a ping pong ball cannon. I'll also bust out with my large ping pong ball cannons and some other things that are pretty powerful when it comes to air. You guys have been awesome. Leave comments below if things you'd like for us to do. I know folks have asked about forces of motion, light and sound, some physical chemical changes. We've got stuff to do all of those things here, so we're building out a mini curriculum for you guys to enjoy at home. Let us know what you want us to do. Get the Scrub It Up Challenge going at your house today. Post the video. And until next time, keep learning. All right, well, take care. Have a good one. Bye, guys. Oh, no, I can't hit the button.